Hello, this is an update from of my package of the Jetbot. A quick explanation. Here I have added some image only, image for the work that I've been doing with Gazebo and the Intel Realsense. Let's check. Here you can see in Gazebo now the Intel Realsense and also in the Rviz interface. Here is the Intel Realsense attached to the body of the Jetbot AI Kit, and also we have an image of the point cloud. Here is the code can. One thing you need to know is that the code can is near. If it's very near to that camera, you will not see the point cloud. You have to put it far away from the Intel Realsense to get detected. Next, another change that I made, I renamed those files just to be a little bit more explicit. For example, this will launch only Rviz. This will launch only Gazebo, obviously with the Jetbot. And this one will launch Rviz and Gazebo with the Jetbot. The three files launch the Realsense and the point cloud if you enable it. What is that about? You can enable the Realsense camera, and also you can enable the point cloud visualization. By default here is I will put it on true because to test the flexibility of the package in the future. True, and here true. Okay, that's fine. Let's see the most simple example with Rviz. In Rviz, I am using these two variables, point cloud enable and Realsense. So if you want to launch this file, it will load the Jetbot xacro that has all the definitions of the wheels, chassis, antennas, and the Intel Realsense, and pass these arguments to the model. Finally launch the model in Rviz and also the joint state controller, and publish the joint states of the robot. So next thing we can see is that in the gazebo is practically the same. I'm putting on the xacro file of the Jetbot, the point cloud, and the Realsense enable flags, launching gazebo, and the same thing in the whole file from Rviz and gazebo. So when you launch, if you disable Realsense, you only see the Jetbot without the Realsense attached in front, just with the RGB camera of the Jetbot that comes with the kit. If you point this variable to false and Intel Realsense to true, it will only launch Realsense and the Realsense camera with all the topics of that image, infrared, all those topics. But you will not see the point cloud. Also, if you want to see the point cloud, you have to enable the point cloud, launch the file again, and you will see this image here. Let's see, something like that. Remember, you have to, in Gazebo, you have to put away the code can to see the point cloud very clear. So you can enable, disable, because I'm using xacro to enable and disable the camera. So what I did to add the Intel Realsense, well, I used the Pal Robotics repo. They made a great work about making a plugin. So I don't remove the wheel, I use the plugin. Let's here, let's see. This one you can download from Poly Robotics, and if you do a custom make, it will be loaded perfectly. So if you build the Intel Realsense Gazebo plugin, you will see something like uh, this one. This is loaded on the xacro file of the Intel Realsense to load the point cloud and all the necessary drivers to load to make it happen the point cloud inside the Jetbot simulation in Gazebo. So let's see where I put my Intel Realsense. So okay, another thing that I did was that I ordered in a better way the Jetbot xacro. As if you see here, let's close that. If you see here, I only include a file only, and also made the chassis and the camera xacro files for just only call it. Make a xacro if here you can load the Realsense and also load the point cloud if you want it. So in the includes file here, you will see here is the materials for gazebo, the Jetbot xacro file that I renamed it, and the transmission xacro, inertia, chassis, antenna, wheels, caster, RGB, cam, and the boards and the Intel Realsense. So how do I include it? First, I got the meshes here. I got the mesh of the Intel Realsense. You can check my previous videos. I made a package to just load the Realsense in Gazebo and Rviz, so you get exposure of how I did it. Here is for only the renderization of the render, I mean, of the mesh. This is the file, the documentation, that's not matter. Here the URDF and includes gazebo. We have here the 435 gazebo xacro. Here we have below is the plugin. There is the plugin. You can see it. This is from the package Realsense Gazebo plugin that we got from Poly Robotics. So next, what I did was this is from Gazebo. Let's see the sensors. URDF includes parts, sensors. Okay, and also I got this file from the Intel Realsense GitHub repository. So here, as you see, you have to include the Intel. You have to include the Gazebo plugin that we mentioned earlier. Sorry, the Gazebo xacro file from here. Yeah, this one. Here, this is the Gazebo xacro file. Xacro name is Gazebo D435. Here is included, and also we have to include the file from the Gazebo xacro for load. And in the end, what I did was to call it finally on my Jetbot xacro file. Where it is? Here. Here. I call it on my Jetbot xacro file. Of course, I have only an include files that have all the files from the xacro macros. Let's see it. Here, have all the files from the xacro macros. So I keep it. I think I keep it in a better way in documenting the xacro. Probably it's not the standard way to organize a folder, but at least give me some sort of order in my package. So finally, let's see where is Jetbot xacro. Here, and you see you can include or exclude Intel Realsense. I have a previous video if you check my channel and in how to load all the variants of the Jetbot with the Intel Realsense and also see the topics. I will launch here the application with the Intel Realsense and also the point cloud library. So you have to do just launch Jetbot D435. We will launch the complete file Jetbot Rviz gazebo launch, and if you want you can enable these arguments, but by default they are explicitly here predefined by default. They have their default, so you can omit that. Of course, if you don't want the point cloud, you can do point cloud enabled false if you don't want the point cloud, but by default it's enabled. So let's see. Let's launch the Rviz gazebo. Oh. Okay, here you will see. Okay, good. Let's see what I'm talking about. What happens if you put the code can near the Jetbot? Let's zoom a little bit. Okay. So when you go to Rviz, you will see this. The beam is interrupted, but we cannot see the code can. So the next thing that you must do is to click here and move the code can a little bit far away from the Jetbot, and you will see in Rviz the update image of the point cloud here. So if you want to disable all these TF frames, you here just only click here and you see all the information of the point cloud clearly. Let's see. Okay. Okay. Here you can see point cloud. Also, you can play with the parameters here. If you want to check only the raw image of the Jetbot camera, you can change from topic, image raw. Here you can see the code can. If you want to play with RQT and so on, or the joint control or the robot steering, next you will see the point cloud will move. That's because we're moving the robot. So you will see on gazebo that we're moving the robot counterclockwise. Also will map the point cloud clearly in Rviz. So that's all. I hope you like the update. I will try, I don't know if this week or the other one, to add a LiDAR below above this box, just to keep the simulation complete, and try to do some sort of arrangements to work with the LiDAR also. So you will have a camera, you have a 3D depth camera with the point cloud and also a LiDAR. So it will kind of a little bit complete project for simulation, and also use other complex package. So that's all, and thanks for watching.